guys, welcome back to my channel here today. And today, if you can see the title, I want to talk about 5 things that I wish I knew before I studied computer science. You can see I have a change of background, and so I'm just trying something new here. I also have my headphones in because I don't have a mic, so I try to use my headphones mic so that I could pick up sound. I want to start with I had a video talking about why I transferred to be as a computer science major. I kind of have my 2 cents in that video, so if you're interested, you can also, I'll link it here. You can go watch that video if you are a transfer student or thinking about whether or not CS at BU is a good program for you. But other than that, for my other viewers, I kind of want to talk about 5 things that I kind of learned or I wish that I knew before I actually went into study computer science. Because the reason that I went into studying computer science is very random. I kind of like looked at my sister and I'm like, oh, this is cool. And so I went into computer science just because of that. But first thing is that I want to say that computer science is not just about programming. Like, I'm sorry I have to break it to you, but computer science has a lot of theory. It's very theory involved. If you want to do a master or PhD, you probably have to take a lot of theory classes. And also, we also have a lot of math, like combinatorial structure, and also we need to learn more about linear algebra. I know that for a lot of people, they need to take linear algebra with like Python to solve like a matrix, that type of stuff. And then like concepts like algorithm, data structure, like linked lists, hash maps, arrays, and also like computational theory. Those are also very essential to understand how software works and how you're actually going to apply to like actual work. I've heard a lot of stories where software engineers actually use math to solve like a software problem. Most of the time, those are because of they want to increase efficiency on the program, to make it faster, to make it run more faster, or make it more storage-wise is also very important when you learn about like data structure on how to store storage or how to find like a good method to find something, to search for something in a very big data set. I don't think it's called efficiency, but it's like the big O notations where some algorithm or some method of if you're using it for searching or finding things in a big data set, it will be more efficient, it runs faster. Those are like things that you're gonna learn in your computer science degree, and also things that's really important when you want to become a software engineer in the future. Like, those are questions that they're gonna ask you during interviews. Like, they'll ask you to solve a question, and after you solve the question, they're like, is there any other more effective way or efficient way that you can solve it, and what is the big O notation of the method that you're using, and is there another way that you can make it more efficient, and what will be the other big O notation is. And then the second thing is also I want to talk about problem solving. Is obviously essential skills, especially for computer science, because a lot of the times you're using software to solve a particular problem. And so whether you're doing any like back-end work or front-end work, a lot of the times you have to use your problem solving skills to like debug your code. A lot of the times I've heard like coding or being a software engineer, 70% of them 30% of the time you're actually coding, and then 70% of the time you're actually really just debugging your code because there's so many bugs out there. A lot of the times libraries or like languages or frameworks will get depreciated, and then you kind of have to solve it in that sense, where you have to update your package or update your library so you have the most updated library, so that when you pass on to someone else, and if your app like continuously improving, it will have less complication in the future. So the ability to think critically is also very important, to like think about the solutions, think about how to make it more efficient. I can't say the word efficient because it always makes up with effective. And also just be prepared to like use a lot of your time, like whether in your homework or exams, to just hone it into your problem solving skills. And a lot of the times you're trying to break a very big complex problem into smaller bits so that you can kind of solve them one by one, and then like at the end you kind of have a whole solution. And then if you need to be more efficient in your solution, you can like kind of go from there and improve upon your existing solution, which is always a good thing because they know that you're able to solve a problem, and then you kind of you can break it down into smarter bits. But again, that's another story for another time. And then third thing I want to talk about is that there is a lot of self-learning. Whether you're trying to become an actual software engineer or just a front-end or a back-end engineer, a lot of the times, even in school, I did a lot of self-learning. I watch a lot of YouTube video even after our lecture. We get confused and we go to office hours, but then there's so many people in office hours that it just doesn't help. So a lot of the times I look up YouTube video, trying to find other better explanations or more digestible explanations from other YouTubers that teach us stuff like that. And then for front end, I think it's coding with Mosh that I really like when I was learning about my front end, React Native, even HTML and CSS. I always like to look at existing tutorials and kind of copy them and then learn it and then apply it in my skills or add in my own kind of sprinkly here and there, adding my own styles to it. So those are the ways that I kind of try to learn computer science or front end in general for me. And even for theories, I like to watch, there's this YouTube channel, I forgot their name, but they have really good explanation on data structure. A lot of the times I look up data structure videos to help me understand and visualize how it actually works, so it helps me through my degree. Not saying professors are bad in general, but a lot of times they are very busy and they don't have enough time. And even for TAs and CAs, they are very busy, but they're just busy in general and they don't have enough time for us, and so we kind of have to learn it by ourselves. And then fourth is real life application is actually very different than classroom learning. They can be quite different from what you learn, because what you learn is you learn theories, you learn the practical stuff, but in real life you kind of have to pick up whatever is left from the previous engineers and then learn the other engineers how they write code, and then you have to continuously writing on them as well. In class they teach you how to use Linux, Unix, they teach you assembly language, they teach you basics of each language, but you don't really go in depth as into how to read other code and how to implement your code to other code. That kind of stuff is kind of you kind of have to do it yourself and just learn it as you go. So for example, having practical experience internships, passion project, or any other open source projects are all very invaluable for your experience in general, because in those places you can kind of learn as you go and learn how to pick up other people's code in that sense. And then number 5 is just that continuous learning is a must. The field of computer science is very dynamic, it's continuously evolving. There's always new technologies coming up, programming languages are popping up here and there. Programming languages that might be popular in the 80s or the 90s might not be as valuable as right now. Beforehand they use a lot of C++, they use even Java and Pythons are more recent languages. They use Ruby. There's a lot of other programming languages that we haven't heard of, but they still use it. For example, they use Go for Google just because they created it. And then we have Flask, we have Ruby, we have C#, C++. There is just a lot of languages you have to learn as you go into your job. So there's Copilot recently launched, so you can have to stay updated with the current technology trend and be open to just learning new technologies, learning new tools like Dockers, Kubernetes. But yeah, there's just a lot of technologies evolving and coming up as we go into the modern world. And so that's kind of this, I wouldn't say struggle, but kind of the struggle that you have to face if you want to stay in the tech industry. And as a software engineer, you have to learn other programming languages as you move forward into your career and want to be successful. You want to stay on top of the trends so that you don't fall behind. But yeah, and I think those are the 5 things that I wish I knew before I studied computer science, and I hope those are valuable for you to listen and decide whether or not you want to go into the computer science field or not. And so that's the end of today's video. I hope you guys enjoyed it. If you want to follow more of my content, you can click the subscribe button and the bell button so you get a notification whenever I post. But yeah, thank you for watching and stay tuned, and I'll see you guys next time I post. Bye!